Okay, so in 5.5, we're going to be working on inverses. Inverses are also called, like the inverse of sine is called the arc sine, the arc cosine, the arc tangent. So that might be something you've heard of before. And we're going to relate these inverse trig functions to the graph. Okay, so inverse functions have some restrictions on them, and the graphs are going to help you understand why those work the way that they do. So recall that for a function to have an inverse, it must be a one-to-one function, which means for every input, there's exactly one output, but the trig functions are not one-to-one. Because like we just talked about, there's more than one place on a unit circle that has some of these values. There's more than one place where the sine value is 1/2. There's more than one place where the cosine is √2/2. So by that definition alone, the trig functions would not have inverses. We can also verify that with the horizontal line test. So we just graphed sine and cosine functions, and we have this wave. According to the horizontal line test, it would not pass it, and so you wouldn't have an inverse. What we're going to do is we are going to restrict the domains of the trig functions in such a way that the resulting functions are one-to-one. Okay, so we're going to look at the sine function and its inverse. So we're going to have an interval that's 1-to-1. So I couldn't make it from 0 to pi, because do you see at 0 to pi it would not pass the horizontal line test? So when we restrict this, we're going to restrict it from here to here, which you can see is -pi/2 to pi/2. So if you do that restriction, it would pass the horizontal line test. This is the graph of sine. Okay, this is the graph of sine on the interval -pi/2 to pi/2. Okay, so it is going to be a one-to-one function here. Now I want you to look at the inverse. So this is the inverse of sine. Okay, can you tell me what the domain is of that? So when you're finding the domain, remember you're finding the lowest x value to the highest x value. We're going to do the same thing with the range. Okay, so what's your lowest x value? -1. Okay, so it's just right here, right? This is the lowest it goes to on your x, -1. The highest value is +1. Okay, and then your range, lowest y to the highest y. So the lowest y value it reaches is -pi/2. The highest y value, pi/2. Okay, it's on that restricted graph. Okay, so based on that, that is how we are going to find the inverses. So the inverse sine function has this symbol, or it's called the arc sine, and the domain is -1 to 1. The range is -pi/2 to pi/2. Okay, so that's how it's defined. So you might remember last year when we were talking about these, I had you guys draw a visual. So -pi/2 is here, pi/2 is here. So if that's the interval, then what quadrants does that cover? So if you go from negative pi over 2 to pi over 2, that covers which quadrants? 1 and 4. So that means the output can only be in quadrant 1 or 4, okay, for the sign values. There are also some cancellation properties that can be used, but they can only be used if it falls within the correct domain. So in order for those to cancel, x would have to be between negative 1 and 1. In order for the sine inverse to cancel out the sine, it would have to be in between negative pi over 2 to pi over 2. And we'll explore that further when we go over these examples. Okay, so we're going to find each value. So when you have the sine inverse of root 2 over 2, you are answering this question. Find the number in the interval, negative pi over 2 to pi over 2. Okay, and by number, I really mean you're finding the radian. You're finding that radian value in this interval, whose sine value, so the sine value is the y-coordinate, is root 2 over 2. Okay, and it has to be in quadrant 1 or 4. So think about quadrant 1. Okay, where is the y-coordinate, root 2 over 2? At pi over 4. Okay, so that's your answer, pi over 4. Okay, so you aren't going to have to show work for all of these. Okay, there are 2 places. This is 1 pi over 4. This is 3 pi over 4. Okay, at 3 pi over 4, your y value is also root 2 over 2. Okay, but it's not in the interval. Okay, that's why your answer is pi over 4 and not 3 pi over 4, even though they both have the same y-coordinate. Okay, so you have to limit yourself to the restricted quadrants. Okay? All right, and then for B, you're going to do the sine inverse of negative root 2 over 2. So I want you to give that a try. Okay, so the sine inverse of negative root 2 over 2. Okay, so the question you are asking yourself is, where in quadrant 1 or 4 is the y-coordinate negative root 2 over 2? Okay, so your train of thought might be that at pi over 4, that's where I know the y-coordinate is root 2 over 2. So based on that, I know it's going to be negative in quadrant 4. Okay, this is where it would be root 2 over 2, negative root 2 over 2. Now, normally we call this 7 pi over 4, but 7 pi over 4 is not between negative pi over 2 and pi over 2. Every angle has 2 names, a positive name and a negative name. So instead of calling this by the positive name, which would be going counterclockwise, we just have to call it by its negative name, which would be what? 7 pi over 4 is the same thing as what? Negative pi over 4. Okay, so your answer to this is negative pi over 4. Okay, which honestly I think makes it a little easier, because if you know pi over 4 is root 2 over 2, it's just negative pi over 4. It's just the reflection. Okay? Okay, what questions do you guys have for me on A or B? We starting to remember this a little bit, the inverse? All right. For part C, we have the sine inverse of 5/4. And D, we're going to do the sine inverse of the sine of pi over 6. Okay, and I know you can see I wrote some guidance on there, but I want you to just look at part C and notice some things about that. Okay, so first, when you see 5/4, right away you're going to be thinking, hey, there's no place on the unit circle where it is 5/4, okay, and that's true. Remember that your domain has to be -1 to 1, but 5/4 is greater than 1. So if it's not in the domain, okay, if it's not between -1 and 1, if it's greater than 1, or less than -1, okay, that's the domain for the sine inverse, then it's going to be undefined. And that's what you're just going to write for your answer. So this equals undefined. Okay, so when you start like looking at numbers and you're like, oh, that I don't know where that is on the unit circle, that's not one of the special points, then you should start analyzing, hey, is it bigger than 1 or less than -1? Okay, because then it's likely that it's going to be undefined. Now, we did talk about those cancellation properties, and we said that there are certain intervals. So they are going to cancel out if your value is in between -pi/2 and pi/2. So if it's between -pi/2 and pi/2, it really just is going to be pi/6. It's just going to cancel. So since pi/6 is in this interval, you can use the cancellation properties on that first page of the inverse function. Okay, but for this one, this is not in the domain in this interval, -pi/2 to pi/2. So if it's not, then we're going to have to evaluate. Okay, so 13 pi/6 is definitely greater than pi/2. So then what we're going to do is evaluate inside. So sine of 13 pi/6, we can find out what that is. Go ahead and find it. And then once you find it, you're going to plug it back in and then evaluate the inverse sign. If you're not sure where to start with this, I would start by thinking about what the sign is at pi/6. That's your reference angle. Okay, and you know 1 full time around the circle is what pi/6? Yeah, 1 time around the circle is 12 pi/6. Okay, so 13 pi/6 is right here, the same place as pi/6. Okay, and so it's √3/2, 1/2. Okay, so your sine is 1/2. Then all you have to do is evaluate the sine inverse of 1/2. Again, you just have to make sure that you're answering this question. Where is the y coordinate? 1/2 and q1 or 4. Well, if it's positive 1/2, we just wrote this out, right? It's at 13 pi over 6, which is the same place as pi over 6. Okay, so that's going to be your final answer, pi over 6. So see how you can't just cancel those out there? All right, now for the inverse cosine function, we're going to do the same type of thing with the restriction, but we can't use negative pi over 2 to pi over 2 again because that wouldn't pass the horizontal line test. So instead, we're going to use 0 to pi. So if we use 0 to pi, then it's 1 to 1. Okay, so this is the graph of the cosine. Okay, this is the graph of the cosine from 0 to pi, which means we're going to be looking at quadrant 1 and quadrant 2. Okay, so I want you to write the domain and the range for this inverse function. What's the lowest x? What's the highest x? What's the lowest y? What's the highest y? Okay, so for the domain, when you're looking at your x values, it's -1 to 1. And that makes sense because both sine and cosine have a minimum of 1 and a maximum of, a minimum of -1 and a maximum of 1. So when you do the inverse, that range becomes the domain. Okay, the range is just going to be 0 to pi. Okay, so 0 is here, pi is here. Okay, so this is going to be in quadrants 1 and quadrants 2 because you have 0 to pi. Okay, and your domain is -1 to 1. Your range got cut off here. The 0 got cut off, so we'll just write that in. Should be 0. All right, and then your domain is -1 to 1 for the cancellation property and 0 to pi for the second cancellation property. All right, I'm going to let you guys try these. So we're doing the cosine inverse of -√3 over 2. The cosine inverse of cosine 5 pi over 6. Okay, and if you want to work with your row, you can. If you want to try it on your own and check with your row, you can do that. So as we're tackling the first one, I always find it helpful to think about where in quadrant 1 is the cosine root 3 over 2. So we know at pi over 6, it's root 3 over 2, 1/2. So if I'm trying to find where it's negative, if I'm looking in the first two quadrants, I know it has to be this reflection point. Okay, so this is going to be at 5 pi over 6. And you can either count by pi over 6, or you can know that this is 6 pi over 6, so that's just one less. And so your answer for this is just going to be 5 pi over 6. So you're doing the reflection there. Okay, so I always start with my first quadrant and use that as my starting point. Now, if this value is between 0 and pi, you can just cancel. So, yep, that's in between, so it's just going to be 5 pi over 6. 7 pi over 6 is not in between. So we are going to find what that is. Okay, so the first thing we're going to do is find the cosine at 7 pi over 6. So I'm just going to use the same sketch I did here. This was 6 pi over 6. So at 7 pi over 6, you can think of all students take classes. The cosine is going to be negative, or you can just know in quadrant 3 it's going to be negative. Okay, so you would get negative root 3 over 2. Okay, we've been working with the root 3 over 2 in this example. Okay, and then your second step is just finding the inverse of negative root 3 over 2, and that has to be in quadrant 1 or 2. So it can't be in quadrant 1 if it's negative, it has to be in quadrant 2. So it's right there at 5 pi over 6 again. All right, and then the last inverse we're going to talk about today is the inverse tangent. So the inverse tangent is 1-to-1 from negative pi over 2 to pi over 2. Okay, and the domain, if you look here, the x value, it's going to negative infinity to infinity. So your domain is all real numbers. Okay, and that's going to be nice if you have a cancellation because you can work with any value. Okay, your range is negative pi over 2 to pi over 2, which means again you're in quadrant 1 and 4. Okay, so you have your negative pi over 2, this is your pi over 2. You can see that visually on the graph. Okay, so last year I was just telling you, hey, it's in quadrant 1 and quadrant 4. But now we can see why. It's based on that graph, okay? So the inverse tangent function is this symbol. It's called the arctangent or the arctan. Your domain is going to be all real numbers. And your range, negative pi over 2 to pi over 2. Oh, and they did put the soft brackets there because really you're what's going to happen at pi over 2 and negative pi over 2. So you have an asymptote there, which means it's what? Yep, but what happens on the unit circle? What's your tangent value? Undefined. So let's change those to parentheses. Right? It's undefined here. Undefined here. We'll change those to parentheses instead of brackets. Okay, and then again, it's still the Q1 and Q4. So your negative pi over 2 to pi over 2. you're going to find each value. Oh, also the cancellation properties. So if you're doing the cancellation for tan of the tan inverse, all real numbers, so for any values, and negative pi over 2 to pi over 2 if we're doing the tan inverse of tangent. All right, so I'm going to have you try these first two. The tan inverse of 1 and the tan inverse of negative root 3 over 3. Hey, if you are struggling with the first one, the second one, A and B, one thing I recommend is to write out your tangent values for pi over 6, pi over 4, and pi over 3. So remember at pi over 6, it's root 3 over 3. Pi over 4 is 1. Root 3 is 3. So the tangent inverse of 1, where is the tangent 1? At what value? What do you guys get for A? Pi over 4. Okay, now when you have the negatives, let's just extend this here. Okay, so this would be negative pi over 6, negative pi over 4, negative pi over 3, and these would all be negative. Okay, because it's either in quadrant 1 or quadrant 4, right? So negative root 3 over 3, your answer is going to be, did you get this? Negative what? Pi over 6. Okay, so not 11 pi over 6, because that wouldn't fit in the interval, but it's negative pi over 6 fourths. Okay, so this is a clear way to see those tangent values. All right, now we are going to do a few where you have a function and an inverse, but they're not the same trig function. To evaluate these, we're going to do just what we did before, where we start with the inside, and then we work our way using substitution. So if we're doing the tangent of the sine inverse, the first thing we're going to do is the sine inverse of root 2 over 2. So this is asking you, where is the y-coordinate root 2 over 2 in quadrant 1 or 4? So what's your answer to that? Yeah, and I feel like this should be immediate, right? Root 2 over 2, we know that's going to be pi over 4. All right, step 2 is the tangent of pi over 4. Tangent of pi over 4 is 1. Okay, so we should be able to do that in like seconds. Okay, if you have this in front of you, that's going to make this go really quickly too, because when you do the tangent inverse of negative root 3, we know it has to be in quadrant 4. So if it's pi over 3 is root 3, what's going to be the tangent inverse of negative root 3? Yep. So if here's pi over 3, we're just going to use negative pi over 3. Step 2, we're going to find the sine at negative pi over 3. Okay, so then let's just write down our point. So I always start with just the first quadrant. So I know this point is 1/2 root 3 over 2. Okay, so when you're doing the sign of negative pi over 3, okay, this point here is 1/2 negative root 3 over 2. Assign the x or the y. The y. Okay, so it'll be negative root 3 over 2. That's your final answer. Okay? Okay, so you do have to turn in your classwork today. Yep. Okay, and then if you are starting to think towards the end of the term, because really it's pretty much here. We don't have a lot of homework assignments left. This is a great one to do just to get a bump if you're looking for a bump at the end of quarter 2, okay?